Welcome to Design Technology at King's School. My name is Andrew Cheney and I work with Mr. Williams, Mr. Fletcher and our technician, Mr. Kingsnorth, to support pupils in their AQA GCSE studies. The GCSE course builds upon the experiences of Key Stage 3. Pupils would have experienced wood, metal and plastic, both marking, measuring, fabricating, developing their accuracy and their attention to detail. They would have also experienced and developed their CAD skills, their computer-aided design skills, and then exported to laser cutters and vinyl cutters. So the GCSE course builds upon this traditional skills and these new technologies and extends it further into an individual design and make project. Now the course is split into 2 units, both worth 50%. The first part I'm going to talk about is the written paper, which is worth 50% of the course. And it's a 2-hour exam that's taken in the summer of year 11. So the written paper covers 3 areas there. Section A, core technical principles. Section B, specialist technical principles. And section C, designing and making principles. Historically, lessons were delivered as theory lessons, but we've moved to a new system where we are using a range of teaching resources, videos, question and answer sessions, and PowerPoint presentations based around PG Online. Now, the PG Online resources are very visual, and we have applied them to these short lessons. So each lesson will start with an element of theory, and the students produce a learning card. You can see in the middle of the slides there at the top. It's a green learning card, and there's different colours for the different topics as we go through. So rather than having a lesson of theory, we have about 15 minutes at the start of a lesson where we go through a concise topic. The students will see a PowerPoint presentation. There'll be question and answers, and then they make some concise notes onto their learning card. And then we support the learning and add some depth to it through some home learning, whereby, for example, if we're studying and looking at the specification requires to know about 6 British designers, we will cover 1 in a lesson, the other 5 will be to be supported through learning at home. And there's resources which go home regularly via Satchel 1, and then every 6 weeks there is a mini assessment in a lesson to check the recall, the retrieval of the home learning, and by this method we hope to cover the specification in an interesting, quite dynamic way in lessons. The first job they do when they start is make their little holder for their storage cards, which you can see there in the middle. So they do CAD straight away. We see how they've learnt and applied their Key Stage 3 learning. We refresh, they do some CAD skills, they laser cut, and they produce their own learning card box, which you can see there, which the students enjoy. So the theory element we hope to deliver in a vibrant, interesting way. We've got 2 textbooks which we refer to. We've got the CGP on the left there, the revision guide, and we've got the PG on PG Online, the publisher, the book that corresponds to the PowerPoint presentations that we've adapted for school. And those 2 texts, one which they take home, the blue one on the left, and the right one which is in school for them to refer to, are our 2 set text. To deliver the theory elements alongside the PowerPoint presentations and the theory work, we then aspects of the theory we teach through practical projects. So if we look at the 3 here, we've got timber and man-made boards, metals and alloys and engineering, and electronics and polymers or plastics. So rather than learn out of a textbook about cutting threads in engineering, or about different wood joints and dovetail joints and mitre joints, etc., they physically make projects in these material areas to develop their knowledge and understanding. We're very much of the opinion that learning by doing embeds that learning and that theory elements far more effectively than just learning out of textbooks. So the first project on the left there, timber and man-made boards. They produce their own storage project. There is hand marking, cutting, lots of hand skills and machine tools, and then the CAD/CAM element of laser cutting their back plate and designing their back plate. There's sketching and communicating through drawing as part of that project. The second project in the middle there, the engineering project, the theory of metals and alloys, and those engineering topics and practical areas of cutting threads and bending, and a bending jig to get the movement and bend there in the brass on the top. And then moving on to the last project, which is all to do with polymers. So they're vacuum forming, they're line bending, they're fabricating electronic and learning about electronics, fabrication, and putting it all together, that little nightlight project. So this is an application of the theory through practical making. That's the first part spoken about, Unit 1 and the theory, and I hope you can see we tried to make that interesting and vibrant. The second unit is their individual design and make portfolio and prototype. So this is work equal weighting, 50%. It's released in the June of year 10, and we've then got through to Easter of year 11 to produce the design portfolio and the practical outcome. So it's got to be a functioning prototype. So the contextual challenge, or the topic, gets released each year in the June, and it might be securing or storing personal possessions. It's one that we've had in the past, so that might lead on to individual safes, a bike rack, anything to do with securing or storing a personal possession. It could be a student, university student moving away from home and wanting to store their valuables in their halls of residence and make their own little storage box. It could be a jewelry box. It could be, securing tools or a bike in the garage. It's quite open and interesting and creative, and allows students to think around the topic and come up with some really interesting ideas. To do it, at the bottom there you can see they've got to make a design portfolio. It covers identifying and investigating the design possibilities, producing a design brief and a specification, generating their ideas through drawing and communicating, isometric sketching, modeling in 2D and 3D, both physically and using CAD. They've got to develop their design ideas, test and model materials, and then physically realize their product, and then analyze and evaluate. A lot to do, but students really enjoy this element that's worth 50%. There's a portfolio, an exemplar one. So we work in A3, we use PowerPoint, they print them regularly so we can see the progress and offer generic feedback. On the right there, you can see there's modeling as they go through. So there's practical elements to the portfolio. There's an example of some sketching, some communicating. So we teach isometric sketching, we teach hidden detail, how to show depth, how to communicate an idea, and that's a real skill in the modern world. As well as using CAD, being able to physically communicate an idea, whatever possible career they might move into, maybe just for DIYing at home, but if they're going to be engineers or designers or work in construction or architecture, it's a really important skill to develop. On the right there, you can see a prototype that's now been moved forward. There's a sort of functioning sort of model with a circular top and a pull-out drawer. They then move to fabricating their idea. This is the part that students enjoy. You can see at the top right, the tool cupboard, all the hand tools. There's planes, coping saws, chisels, all those traditional hand skills that we want to develop. The machines down the bottom left, so they can use power fret saws, power sanders, vacuum formers, line benders, and then the two screens are just the two workshops where you can see the computer screens and the IT that's available. This is open for students in clubs, in evenings and weekends, which are published at the teacher's sort of discretion through year 10 and 11. So for some examples of some outcomes and what they look like, again, fully functioning. This was the previous years. They've got some speaker systems, some storage systems. And there's a second slide there of some others in our cabinets. I hope you found this interesting. If there's any questions or advice or support you'd like, I'd be very happy to help and support. But I hope you can see that the course is about practical learning, but there's also that theory element. So they've got to be really understanding from pupils that it's not just all about physical making. we make it as practical as possible, but there's a commitment to studying both in the lessons, the theory elements, and also home learning and these mini assessments that make up a really interesting and we hope exciting course to run. Thanks so much for listening.